Okay, real talk. What's the most dramatic thing we do when a big storm is coming? The forecast turns grim, the wind starts to pick up, and a collective panic sets in. We run to the home improvement store, fight our neighbors for the last piece of plywood, and then spend 3 hours awkwardly screwing it over our windows. It's a frantic, last-minute ritual. We're essentially putting a band-aid on a building, hoping it holds. We're treating our house like it's a delicate vase we have to wrap in bubble wrap. We see it as a fragile shell that needs protecting from the outside world. But what if that entire premise is wrong? What if your house wasn't delicate? What if it was built more like a wrestler than a ballerina? A structure designed not just to withstand a blow, but to absorb it, redirect it, and remain standing, unfazed. There's a method over 400 years old, used by some of the most pragmatic builders in history, that did exactly that. These were people who lived at the mercy of the elements, who couldn't afford for their homes to fail. Their survival depended on building smarter, not just stronger. And their secret has nothing to do with what you put your house, and everything to do with how its bones are tied together. This is the story of the Knapen house, a survivor from another era, and the secret that made it untouchable. Let's set the stage. New Amsterdam, 1650. The Dutch are settling on the wild edge of a new continent. They've got wind, they've got rain, they've got brutal, unforgiving North Atlantic storms that think their little wooden houses are toys. These weren't just afternoon thunderstorms. They were gales that could last for days, testing every nail, every joint, every decision the builder made. Failure wasn't an option. These builders didn't have hurricane straps or impact-rated windows. They didn't have building codes or computer models. They had oak, pine, hand-forged nails, and a profound, almost intuitive understanding of one thing: triangles. It was a piece of geometric wisdom passed down through generations, a truth discovered not in a lab, but in the real-world laboratory of wind and weather. You see, a square or a rectangle, the basic shape of our walls and floors, is a wobbly shape. It's unstable. Push it from the side, and it wants to collapse into a parallelogram. This is called racking, and it's your house in a windstorm, groaning and shifting as the wind tries to fold it over. But a triangle? A triangle is different. It's a geometric marvel. You cannot deform a triangle without breaking one of its sides or crushing a corner. The lengths of its sides dictate its angles, and those angles cannot change. It is the only inherently rigid shape in 2 dimensions. It is nature's strong form, and it was the builder's secret weapon. The Dutch builders and many other old-world craftsmen knew this in their souls. It was embedded in their craft. Their entire framing system was a hidden web of triangles, a skeletal system designed for resilience. And the crown jewel of this system, the piece that did the most work, was something called a wind brace. All right, quick riddle to see if you're thinking like a 17th century carpenter. I am not a nail nor a beam, though I work with both. I am the difference between a standing house and a pile of sticks. I turn a wobbly square into an unbreakable triangle. I am the secret muscle, the silent guardian hidden in the walls. What am I? Keep it in mind. The answer is the hero of our story. The old world secret wasn't about massive strength, it was about intelligent rigidity. They used a timber framing method called bent framing. Imagine a giant uppercase letter A made from huge timbers, 2 vertical posts connected by a horizontal tie beam with rafters rising to a peak. That's a bent. It's a cross-section of the house, assembled flat on the ground. Now, line up several of these A-frames, raise them into position, and connect them along the top with long beams called plates, and you have the skeleton of a house. But here's the magic. Connecting the vertical post to the horizontal beam at the corner of that A is a diagonal brace, the wind brace. This simple angled piece of timber is the key. It turns that corner from a weak 90-degree angle, which wants to fold, into 2 rock-solid triangles. This brace takes the lateral push of the wind, the force that wants to topple the house, and cleverly transfers it down through the frame and into the foundation, instead of letting it rack the building sideways. It's like putting a hand on your hip to brace yourself against a shove. Your arm, torso, and leg form a triangle. The force doesn't knock you over. It travels through your skeleton and into the ground. The wind brace does the same for the house. The whole structure becomes a single unified entity, working together to resist the storm. Now, let's translate this to your modern home, which was probably built with something called platform framing. It's faster and cheaper, relying on smaller, standardized lumber and lots of nails. But structurally, it's like a stack of boxes: a foundation, a first-floor box, a second-floor box, and a roof on top. It works, but it lacks that inherent integrated rigidity unless it's properly tied together. And your house's weakest point? The attic. Specifically, the connection between the roof trusses and the top of the walls. In a high wind, the roof isn't just being lifted by suction. It's being pushed sideways with immense force. If that connection between the roof and walls, often just a few nails, fails, your roof becomes a giant sail, catching the wind and peeling away. Once the roof is gone, the boxy structure of the walls loses its lid, and they become dominoes, ready to collapse. The old world solution is simple, elegant, and effective: permanent, structural diagonal bracing. In a modern attic, this can mean adding metal T-braces or robust wooden braces that run from the top of the wall plate diagonally up to the roof rafters. By doing this, you are creating, you guessed it, a series of triangles. You are retrofitting the wisdom of the past into your modern home. You are installing wind braces. You are giving your house a skeleton. Riddle answer time. The answer, of course, is the wind brace. That simple diagonal timber is the unsung hero. You are now officially smarter than a hurricane, or at least you understand its favorite weak spot and how to fortify it. But what if you can't go hacking into your attic? There's an even simpler, more Dutch principle you can apply, one that complements the idea of triangulation: the overbuilt connection. They didn't just use smart geometry, they made every connection absurdly strong. They used massive timbers joined with complex woodworking, mortise and tenon joints, secured with wooden pegs called tree nails. The point of failure wasn't the joint, it was the timber itself. You'd have to break the beam before the connection gave way. For you, this means one thing: screws, not nails, and long ones. A nail relies on friction along its shaft. A screw has threads that mechanically grip the wood fibers. When you secure your roof sheathing, use longer screws that penetrate deep into the rafters. When you build a fence or a deck, choose screws over nails for critical connections. When you attach your deck ledger board to your house, use massive lag bolts that go deep into the house's framing, not just into the siding. This connection is what keeps your deck from peeling away from your home. When you install a storm door, use the thick, long screws that come in the box, not the dinky ones you have lying around. The manufacturer included them for a reason. They are part of an engineered system designed to resist force. Every time you choose a longer, thicker fastener, you are mimicking the overbuilt philosophy. You are making the connection stronger than the material it's connecting. You're ensuring that the weak point isn't the joint, but the wood itself. A storm can't rip something apart if there's nothing left to tear. It's a simple shift in mindset that has a profound impact on your home's durability. So, the next time the forecast turns ugly, don't just look at your windows and see a place to nail some plywood. Look at your house's skeleton. Think about its geometry. Think about triangles. Think about how every part is connected to the next, from the roof down to the foundation. By understanding and applying this 400-year-old secret of rigid triangulation and overbuilt connections, you're not just preparing for a storm. You're adopting a philosophy of building. You're building a legacy of resilience that would make a Dutch master carpenter nod in quiet respect. Your house isn't just a shelter. It's a system. It's a statement. And with a little old world wisdom, that statement is that all you've got?